Alright guys, this is our Unit 1 test review. Okay, so I'm looking at number 1. We're going to solve the equation for the given variable. So number 1, I'm looking to solve for x. The first thing I need to do, inverse operation of minus 10. So I'm going to add 10 to both sides. So those cancel out. You're left with 2x over here. On the other side of the equal sign, you got 30 plus 10, you get 40. Alright, so this is 2x. That means 2 times x. Again, the inverse operation of times is to divide. So divide both sides by 2. Those cancel out. You're left with x equals 20. There's your answer. Number 2, 6y minus 2y plus 8 equals 12. Well, guess what? These are like terms because they are the same variable raised to the same power. So I can combine those right off the bat. 6 minus 2, that gives me 4y. And then I bring down the plus 8 equals 12. Next up, I want to get rid of the plus 8. I want to isolate for the variable. Right, so I'm going to leave the 4y there. I need to get rid of everything else. So the opposite of plus 8 is to subtract 8 on both sides. Those go away. You get 4y equals 4. And then last step is to divide by the coefficient. So we're dividing by 4 on both sides, and we get y equals 1. Number 3, I need to distribute my negative 2 to both terms inside the parentheses. Again, distribute means to multiply. So you've got negative 2 times 2x, you get negative 4x. And then a negative 2 times a negative 6 gives me a positive 12. And that still equals 8. Alright, now from there, again, we're going to isolate for the variable. Alright, so I need to get rid of this plus 12, so I'm going to subtract 12 on both sides. That cancels out. You're left with negative 4x over here, and that equals negative 4. Next step, I want to divide by the coefficient. So I'm dividing by negative 4 on both sides. X equals positive 1, not 0. Alright, number 4, I want to isolate for the variable, right? So I will need to get rid of this minus 7. The inverse operation by minus 7 is to add 7 to both sides. So you get 2/3 x equals 16. Again, we're going to take the reciprocal, right? We're going to multiply by the reciprocal. What that means is to flip the fraction. Okay, so this 3 comes to the top, the 2 goes to the bottom. So I'm multiplying by 3 halves on both sides. Again, all I do is flip the fraction and multiply on both sides. These cancel out. You're left with x equals 24. Okay, this is 16 over 1, so I did 6 times 3 and I got 48. 2 times 1 and I got 2. 48 divided by 2 is 24. That's how I got that number right there. Last one, number 5. I'm going to multiply by 3 on both sides. I need to get rid of this divisor first. So I'm going to multiply by 3 over here and over here. These cancel out. You get x minus 2 equals 30. Last step is then to add 2 to both sides. X equals 32. Number 6, 7, and 8, 9, and 10, I want to state the domain range and then determine if it's a function. Alright, so looking at number 6, I want to take the domain. I'm looking at the function there, and I see an arrow. Right, so my domain starts at negative infinity. Anytime I see that arrow going that way, I know it starts at negative infinity. Doing my inequality symbol, infinity is not a number, so it cannot be equal to. Okay, so x is between negative infinity and stops right here, so I'm looking on the x-axis. Where does that stop at? It stops at 5. Okay, and it's an open circle, so it is not included. So there's your domain. Your range, you're scanning the bottom to the top, so the first point on the graph is going to be right here. Go over to your y-axis. It starts at negative 3. And it does touch at that point, so it is included. Your range is your y's. Okay, and then that arrow keeps going up, so that line right there would keep going up. It stops at infinity. And then is it a function? You use your vertical line test. Yes, it is. Number 7, same thing, domain range. Okay, the domain, now I do not have an arrow. So the domain starts at negative 6. It's a closed circle, so it's included. And it stops at positive 6. Same thing, closed circle, included. Range, scan bottom to top, it starts right here. Go over to the y-axis, it starts at 0. Closed circle, so it's included. And then it goes all the way up here to positive 5. Closed circle, so it's included. Is it a function? Yes, it is. Number 8, you have discrete function here. It's just a bunch of points. All right, so your domain is all your x values. So you have a point right here at -5. You have a point at -2, point at 0, and 2 points at 3. Just list it once. Your range is all your y's. So you're looking at a point at -2. You've got a point at -1. Got a point at +1, point at +2, and a point at 5. Is it a function? No, because the vertical line test right here at x equals 3 touches twice. Not a function. Number 9, you're looking at a mapping. Okay, so the domain is -1, 0, and 1. Your range is all your y's, your outputs. Your range is 21, 16, and 12. Is it a function? No, because 0 maps to 16, 0 maps to 12. Not a function. And then last one, number 10, your domain is all your x values, so -2, -1, 0, 1, and 2. Range is all your y's, so your range is these, 4, 1, 0, 1, and 4. Well, we already wrote 1 and 4, so we don't have to write it again. Is it a function? Well, let's look. -2 maps to 4, -1 maps to 1, 0 maps to 0, 1, and 2. So my x values do not repeat to a different y value, so yes, it is a function. Number 11, looking at function notation, all you're going to do is take this number, plug it in. Okay, so this f of -4, anytime I see an x, I'm going to plug it in. Alright, so equals -3, but not x. Now x is -4, so -3 times -4 minus 7. So f of -4 equals -3 times the -4 is a positive 12 minus 7. Last step, what's 12 minus 7? 5. Okay, this is going to be done the same way, so I'm going to go down to number 13. Sorry, guys. I'm going to go down to number 13. Okay, again, same thing, f of 6. So the difference between f of x and f of 6 is I plugged in 6 for x, right? Okay, so now I'm going to, anytime I see an x, I'm going to plug in 6. So f of 6 equals -1/2. Again, it's not an x anymore, it's now a 6 plus 5. Alright, so -1/2 of 6 is going to give me a -3 plus 5. So f of 6, -3 plus 5 is a positive 2, equals 2. Okay, now this f of x equals 18. Okay, well, instead of me plugging in x, I'm going to plug in this right here for f of x, because that's what f of x equals. So I'm going to rewrite this as 18, right, because f of x equals that. So 18 equals 4x minus 2. Now all I'm doing is solving an equation, so I need to get rid of this minus 2, so I'm going to add 2 to both sides. 18 plus 2 is 20. So 20 equals 4x. Last step, divide by 4. X equals 5. Number 14, same thing. It's done the same way. I'm going to plug in this -9 in place of here because f of x equals -9. Alright, so -9 equals 2x minus 1. So I want to move this minus 1. Let's add it to both sides. -8 equals 2x. Last step, divide by the coefficient. X equals -4. Flip your page over. Number 15, we're looking at key attributes. So you have a linear function. The domain, again, you see an arrow there, so the domain goes from -infinity to, see an arrow, so it goes to +infinity. Same thing with the range. You see an arrow, so it keeps going down, so the range goes from -infinity. Arrow goes up, +infinity. We're looking at the x-intercepts. X-intercepts are where it crosses the x-axis, so right here at -4, 0. The y-intercepts where it crosses the y-axis, which is the one that's vertical, so you're looking at 0, +2. Is it increasing or decreasing? It's going up, so it's an increasing function. Alright, number 16 is a quadratic. Looking at the domain, so that arrow tells me that it keeps going, so it goes from -infinity. Same thing, arrow tells me that it keeps going to, to +infinity. Alright, so that arrow keep going here. I'm looking at the range. The range starts at negative infinity, right, because both of those go downward with an arrow. But it does not go to positive infinity. It only goes right here. Okay, so let's go track it over to the y-axis. I'm looking at positive 1. There's a point at positive 1, so it's included. Look at the vertex. The vertex is the highest point right here. Okay, the vertex is either a maximum or a minimum, but the vertex right there is the highest point. So you're going to go over to 2, go up to 1, so my point is at 2, 1. Is it a max or a min? That's the highest point on the graph, so it is a maximum. The axis of symmetry is the x value of my vertex, so x equals 2. Right? The axis of symmetry is where it folds over on itself. So the x value of my vertex right there. And then the zeros are where it crosses the x-axis, so your x-intercepts basically. So you have 2 zeros here, it crosses it twice, so an intercept or a 0 at 1, 0 and 0 at 3, 0. Those are called roots and solutions. Same thing as the x-intercepts.